When selecting a fuse for a motor controlled by a variable frequency drive, or VFD, several factors must be considered. Firstly, the VFD input current. VFD generally draw less input current than the motor's full load amps, or FLO, during starting because of the soft start feature. However, the input current can increase during other operating conditions, such as high torque demands or during acceleration and deceleration phases. Secondly, understanding fuse characteristics is crucial. RK1 fuses are designed with a high inrush current rating, making them suitable for applications where high startup currents are expected. RK5 fuses, on the other hand, have a lower inrush current rating and are typically used for lighting circuits or low current applications. Thirdly, the motor's FLA and starting current are important. The motor's FLA is typically specified in the motor's nameplate. The starting current can often be 4 to 10 times the FLA. Now, to address the specific scenario of using a 100 amp RK1 fuse for a 60 horsepower motor operating at 480 volts with a VFD, let's consider a few assumptions. 1. The VFD provides an effective soft start. 2. The motor's FLA is less than 100 amps. 3. The starting current remains within the inrush current rating of the 100 amp RK1 fuse. If these assumptions are valid, then a 100 amp RK1 fuse could be a suitable option. However, it is highly recommended to consult with both the motor manufacturer and the VFD supplier for their specific recommendations. They can provide detailed information regarding the motor's starting characteristics and identify any potential issues associated with using a 100 amp RK1 fuse in this particular application. It is important to consider additional factors. 1. Ambient temperature. High ambient temperatures can significantly impact the fuse's current carrying capacity. Always refer to the fuse manufacturer's specifications for rating factors that should be applied based on the ambient temperature where the fuse is installed. 2. Cable and conduit sizing. The cable and conduit must be sized appropriately to safely handle the potential current draw of both the motor and the VFD. Ensure that the selected cable and conduit meet all applicable electrical codes and standards. 3. Protection coordination. Verify that the fuse you choose provides adequate short circuit and overload protection for the motor and the VFD. Coordination with other protective devices in the circuit is crucial to ensure selective tripping and minimize downtime in the event of a fault. It is essential to select a fuse that effectively coordinates with other protective devices within the system, ensuring that the fuse clears faults quickly and efficiently while minimizing any potential damage to equipment or disruption of operations. This coordination involves carefully evaluating the time current characteristics of all protective devices involved to ensure proper sequencing and selectivity. By coordinating the fuse with other protective devices, you can minimize the extent of any potential outages and prevent unnecessary tripping of upstream breakers or fuses, thus enhancing system reliability and minimizing downtime. It is important to consider the voltage rating of the fuse to ensure that it is suitable for the circuit voltage. The fuse must have a voltage rating equal to or greater than the maximum voltage of the circuit in which it is installed. Using a fuse with an inadequate voltage rating can lead to fuse failure and potential safety hazards. It is also crucial to select a fuse with the appropriate interrupting rating for the application. The interrupting rating is the maximum fault current that the fuse can safely interrupt without failing. The available fault current at the installation location must be less than the fuse's interrupting rating. Using a fuse with an inadequate interrupting rating can result in fuse failure during a fault, which can lead to equipment damage, electrical hazards, and potential injuries. Fuse selection also involves considering the fuse's time current characteristics, which describe how the fuse responds to different levels of overcurrent. These characteristics are typically provided by the fuse manufacturer in the form of time current curves. By analyzing these curves, you can determine how quickly the fuse will trip under various overload and short circuit conditions. This information is essential for coordinating the fuse with other protective devices in the circuit and ensuring that the fuse provides adequate protection for the motor and VFD. Furthermore, proper fuse installation is crucial for ensuring reliable protection and safe operation. Fuses should be installed in accordance with the manufacturer's instructions and all applicable electrical codes and standards. This includes ensuring that the fuse is properly seated in its holder, that the fuse holder is clean and free of corrosion, and that all connections are tight and secure. Regular inspection and maintenance of fuses and fuse holders are also essential for identifying and addressing any potential issues before they lead to fuse failure or other problems. This includes checking for signs of overheating, corrosion, or damage, as well as verifying that the fuse is still within its expiration date. Additionally, it is important to ensure that spare fuses of the correct type and rating are readily available in case of a fuse failure. Always replace a blown fuse with a fuse of the same type and rating to maintain proper protection and prevent equipment damage or safety hazards. When selecting fuses for motor and VFD applications, it is important to stay up to date with the latest industry standards and best practices. Electrical codes and standards, such as the National Electrical Code, or NEC, provide detailed requirements for fuse selection, installation, and protection coordination. Consulting with qualified electrical engineers or technicians can help ensure that you are making informed decisions and that your electrical system is properly protected. Using a VFD offers several advantages over traditional motor starters, including reduced inrush current, adjustable speed control, and improved energy efficiency. However, VFD also introduce harmonics into the electrical system, which can potentially affect the performance of fuses and other electrical equipment. Therefore, it is important to select fuses that are specifically designed for use in VFD applications and to follow the VFD manufacturer's recommendations for fuse selection and protection coordination. In addition to consulting with motor and VFD manufacturers, it can also be helpful to consult with fuse manufacturers for their recommendations. Fuse manufacturers have extensive knowledge and experience in fuse selection and application, and they can provide valuable insights into the best fuse options for your specific motor and VFD system. They can also provide technical support and assistance with fuse coordination and troubleshooting. It is also worth noting that some VFD have built-in protection features, such as electronic overload protection and short-circuit protection. These built-in protection features can provide additional layers of protection for the motor and VFD. However, it is still important to use properly sized and coordinated fuses to provide backup protection and to ensure compliance with electrical codes and standards. Ultimately, the selection of the appropriate fuse for 60 horsepower motor operating at 480 volts with a VFD requires careful consideration of several factors, including the VFD input current, fuse characteristics, motor FLA and starting current, ambient temperature, cable and conduit size, and protection coordination. Consulting with motor and VFD manufacturers, as well as fuse manufacturers, can help ensure that you are making informed decisions and that your electrical system is properly protected. By following these guidelines and best practices, you can minimize the risk of equipment damage, electrical hazards, and downtime, and ensure the safe and reliable operation of your motor and VFD system. Remember to always prioritize safety when working with electrical equipment and to consult with qualified professionals when needed. Proper fuse selection and protection coordination are essential for maintaining a safe and efficient electrical system. When considering the use of a 100 amp RK1 fuse, it is important to verify the motor's actual full load amperage or FLA from the motor nameplate. The FLA should be less than the fuse's continuous current rating. Also, the starting current or inrush current, which can be significantly higher than the FLA, must be within the RK1 fuse's inrush current capability. Consult the fuse manufacturer's data sheets for specific inrush current ratings. Since the VFD provides a soft start, it reduces the inrush current compared to a cross-the-line starting method, but the actual reduction depends on the VFD programming and capabilities. Verify that the soft start function is properly configured to limit the starting current. Also, consider the VFD potential to draw higher currents during acceleration, deceleration, or periods of high torque demand. These operating conditions can cause the input current to exceed the motor's FLA. Monitoring the VFD input current under various operating conditions can help determine if the 100 amp fuse is adequate. Ambient temperature affects the fuse's current carrying capacity. High ambient temperatures can cause the fuse to overheat and trip at a lower current than its rating. Check the fuse manufacturer's dirt tables for temperature correction factors. The cables and conductors supplying power to the VFD and motor must be sized appropriately to handle the expected current. Refer to the NEC Table 310.16 or similar tables for allowable ampacities of conductors. Ensure that the conductors are protected against overcurrent by the fuse. Proper protection coordination ensures that the fuse clears faults quickly and selectively, preventing damage to equipment and minimizing downtime. Consult with an electrical engineer to perform a coordination study and verify that the fuse coordinates with other protective devices in the system, such as upstream circuit breakers. Confirm that the interrupting rating of the RK1 fuse is sufficient for the available fault current at the installation location. The interrupting rating must be higher than the maximum fault current that the fuse may be subjected to. Check with the local utility company or perform a fault current study to determine the available fault current. It's recommended to consult with the motor manufacturer, VFD supplier, and fuse manufacturer for the specific recommendations. They can provide valuable insights into the application and help ensure that the selected fuse provides adequate protection. Regular inspection and maintenance of the fuse and fuse holder are essential for ensuring reliable operation. Check for signs of overheating, corrosion, or damage and replace the fuse if necessary. Document all fuse selection calculations, assumptions, and recommendations for future reference and to comply with regulatory requirements. If there's any doubt about the suitability of the 100 amp RK1 fuse, it may be prudent to use the 100 amp RK5 fuse or the 110 amp RK1 fuse as recommended by the manufacturer. Oversizing the fuse slightly can provide a margin of safety and prevent nuisance tripping, but it's important to ensure that the conductors and other equipment are adequately protected. When choosing between an RK1 and RK5 fuse, remember that RK1 fuses are generally more current limiting than RK5 fuses. Current limiting fuses reduce the magnitude and duration of fault currents, which can help protect downstream equipment from damage. If current limitation is a critical concern, the RK1 fuse may be the better choice. However, if inrush current is a major concern, the RK5 fuse may be more suitable. Consider the type of loads being served by the VFD. If the VFD is supplying power to a motor that drives a critical process, it may be necessary to provide redundant protection to ensure continuous operation. This could involve using two fuses in parallel or using a combination of fuses and circuit breakers. Ensure that the fuse is properly labeled and identified so that it can be easily located and replaced if necessary. The label should include the fuse's type, rating, and the equipment it protects. Train personnel on the proper procedures for inspecting, testing, and replacing fuses. This training should cover the hazards associated with working with electrical equipment and the importance of following safety precautions. Be aware of any applicable industry standards and regulations that govern the selection, installation, and maintenance of fuses. These standards may provide specific requirements for fuse sizing, protection coordination, and interrupting rating. Consider the long-term cost of ownership when selecting a fuse. While the initial cost of the fuse is important, it's also important to consider the cost of replacement, downtime, and potential equipment damage. Choosing a high-quality fuse that provides reliable protection can save money in the long run. If the motor is subject to frequent starts and stops, it may be necessary to use a fuse with a higher inrush current rating to prevent nuisance tripping. Consult the fuse manufacturer's data sheets for specific recommendations on fuse selection for frequent starting applications. If the motor is located in a hazardous location, it may be necessary to use a fuse that is specifically designed for use in hazardous locations. These fuses are typically enclosed in explosion-proof housings and are designed to prevent ignition of flammable gases or vapors. Ensure that the fuse is compatible with the VFD harmonic mitigation features. Some VFD have built-in harmonic filters or reactors that reduce the amount of harmonic distortion in the electrical system. If the VFD has these features, it's important to select a fuse that is compatible with them. Consider the impact of the fuse on the overall system efficiency. Fuses can introduce a small amount of voltage drop and power loss into the electrical system. While this is typically not a major concern, it's important to consider the impact of the fuse on the overall system efficiency, especially in large or energy-intensive applications. Be aware of any potential environmental concerns associated with the fuse. Some fuses contain materials that are harmful to the environment, such as lead or mercury. If environmental concerns are a priority, consider using fuses that are lead-free and mercury-free. Ensure that the fuse is properly disposed of when it is no longer needed. Fuses should be disposed of in accordance with all applicable environmental regulations. If the motor is part of a critical system, it may be necessary to perform regular testing and maintenance of the fuse to ensure that it is functioning properly. This testing can include visual inspections, insulation resistance tests, and time current curve verification. Be aware of any potential arc flash hazards associated with the fuse. Arc flash is a dangerous electrical phenomenon that can occur when a fault occurs in an electrical system. Fuses can help to reduce the risk of arc flash by quickly clearing faults, but it's important to take appropriate safety precautions when working with fuses, such as wearing appropriate personal protective equipment. If the motor is used in a process that requires precise speed control, it's important to consider the impact of the fuse on the VFD performance. Fuses can introduce a small amount of impedance into the electrical system, which can affect the VFD ability to accurately control the motor speed. Choosing a fuse with a lower impedance can help to minimize this effect. Ensure that the fuse is properly protected from physical damage. Fuses should be installed in a location where they are not likely to be damaged by impacts, vibration, or other physical stresses. Consider using a fuse enclosure or fuse block to provide additional protection. If the motor is subject to frequent overloads, it may be necessary to use a fuse with a time delay characteristic. Time delay fuses are designed to withstand temporary overloads without tripping, which can help to prevent nuisance tripping. Ensure that the fuse is compatible with the VFD control system. Some VFD have the ability to monitor the status of the fuse and provide an alarm if the fuse trips. If the VFD has this feature, it's important to use a fuse that is compatible with it. Consider the impact of the fuse on the overall system reliability. Fuses are designed to protect electrical equipment from damage, but they can also be a source of failure. Choosing a high-quality fuse and following proper installation and maintenance practices can help to improve the overall system reliability. Be aware of any potential surge voltage hazards associated with the fuse. Surge voltages can occur due to lightning strikes, switching operations, or other electrical disturbances. Fuses can help to protect against surge voltages, but it's important to use a fuse with an appropriate surge withstand capability. Ensure that the fuse is properly grounded. Grounding is essential for providing a safe and effective path for fault currents to flow. The fuse should be grounded in accordance with all applicable electrical codes and standards. If the motor is used in a critical application, it may be necessary to use a fuse with a remote monitoring capability. Remote monitoring allows the status of the fuse to be monitored from a remote location, which can help to prevent downtime and improve system reliability. Consider the impact of the fuse on the overall system cost. The cost of the fuse is only one factor to consider when selecting a fuse. It's also important to consider the costs of installation, maintenance, and potential downtime. Choosing a fuse that provides the best overall value can help to reduce the total cost of ownership. Ensure that the fuse is properly coordinated with the VFD braking resistor. Braking resistors are used to dissipate energy during braking operations. If the VFD uses a braking resistor, it's important to ensure that the fuse is properly coordinated with it to prevent damage to the resistor or the VFD. Consider the impact of the fuse on the overall system safety. Safety is the most important consideration when selecting a fuse. Choosing a fuse that provides adequate protection and following proper installation and maintenance practices can help to prevent electrical hazards and protect personnel from injury. By carefully considering all of these factors, you can select the appropriate fuse for your 60 horsepower motor operating at 480 volts with a VFD and ensure the safe and reliable operation of your electrical system.